Hello and welcome to C Programming 0 to Neural Networks. Today we are revisiting Perceptrons. We're going to refactor the Perceptron program we made into a better program, basically, a more flexible and more maintainable program. So let's remind ourselves of what it was. This is the diagram. A Perceptron, we have a series of inputs represented by these x's, and we multiply each input by its own sort of determined weight, which represents the importance of each input, and we add up all those results together to make the value of the perceptron, and then we apply a threshold to that perceptron, and if it's above the threshold we consider the output of the perceptron to be true, and if it's below the threshold we consider the output of the perceptron to be 1. And we made a should you apply for a new job AI out of it. So we asked a series of questions where we have to input 0 or 1, false or true. Does the job have a better salary? Yes. Is the travel time better? Yes. Is the job more interesting? No. Does it have better prospects? No. Are you unhappy in your current job? No. No, you should not apply for the new job. And if we put yes to everything, yes, you should apply for the new job. That was it. Really simple, very basic artificial intelligence, basically. And the actual program looks like this. We probably have to zoom out a little bit. We've basically got one great big main function where we handle each question, we do the same routine over and over again, and at the end we add up all the weights times the inputs to calculate the value of the perceptron, and then apply the threshold to the perceptron and output yes or no. So it's a program, it does work, it's just not very maintainable. If we want to add another question, we've got to add all this stuff in again and change the perceptron down here, and it doesn't really look like a C program. It looks like more of a script, doesn't it? So we're going to change that, and we're going to rewrite it, basically, even though refactoring is usually taking an existing program and changing it and remaking it. Because it's quite a small program, we're just going to rewrite it. So I'm going to make a percept.c. Let's zoom in. We're going to include the C standard input-output library as per usual. We're going to make a main function, and we're going to return a 0 to the operating system. So what did we do before? We did float x1 to represent the first input, and we had 5 of them. And 2, 3, 4, 5. And then we had float w1, and we had 5 of them, and we had a float p. So that was all our data, and for each of these we did a scanf to get the input, and we did a printf to get to output the question, and that's how we ended up with the program we ended up with. So we're going to do it a different way this time. We're going to get rid of all that. Well, we've gone through arrays now, so we're going to use arrays. So we're going to do float x, an array of 5 to represent, we're still going to make this kind of model, an array of 5 inputs. And then we're going to do the same thing for w. We're going to have 5 weights, and then we're going to for loop through the weights and inputs as the main sort of engine of our program. So we're going to have int I equals 0, I is less than 5, I plus plus. So the first thing we need to do is clarify what this 5 means. This is obviously the number of inputs, but it's not very descriptive just having a 5 there, so we're going to use a macro. We're going to define input count and set it to 5. Now if we type in input count here, every instance of the phrase input count is going to be replaced by a 5. That's kind of how macros work. So we're going to do that. So there we go. So now we've got our sort of data. We still need a perceptron, don't we? Float p to represent the perceptron. So what do we need to do in our loop? We need to, first of all, output a question. So we could put question 1, but this is going to print out question 1 for every question, isn't it? We can confirm that. Question 1, question 1, question 1, question 1. We need to vary this question based on where we are in this loop. So we can't just output a string in a sort of fixed string. We need to actually have a string placeholder and replace that with a value of some kind. Now there's various ways. We could have an array of strings, for example, but that probably wouldn't be the best approach in this example for this Perceptron program. What we really want is a function that returns a string. So we want to get question function, and we can define that up here. We can do car, we need star to represent a string literal, which I haven't covered yet, but a string literal is just a read-only string. Get question, and now we can return a question 1, for example, and then this function, when it runs, it will return whatever is returned, and that will be printed out by the printf function. Let's confirm that works. I've spelt something wrong. Get question. Get question 1, question 1, question 1. So we've got the same thing as before, but now we've got a function handling what's printed out by the printf, and we can vary that output based on the position we are in this for loop, which is determined by I. So we need to pass I to our get question function, don't we? And we need to accept that I, which is an int I. And now we can switch on the value of I. And if the I is 0, we can do case 0, break, and we can put the return in there. We can do case 1, case 2, case 3, case 4, question 1, question 2, question 3, question 4, question 5. So when this get question function runs, it will return a different answer depending on the value of I. So let's see if that works. And sure enough, it does. Question 1, question 2, question 3, question 4, question 5. Fine. So shall we define a question? What are we going to ask this time? We don't want to do the job example again, do we? Let's do, should you learn the C programming language? Let's make that the question. Kind of topical for this series, isn't it? Do you like computers? Probably an important part of whether you want to learn C programming. Do you like programming? Question mark. What's the next question? Are you dedicated? Probably need to be quite dedicated to learn C programming language. Are you willing to give up your social life? Not necessarily required, but it certainly helps. What's the last question we're going to put? Can you copy paste? Can you copy paste? It's probably an important part of all programming languages, isn't it? We'll do a bit of copying and pasting from time to time. So let's have a look at how that looks. Yeah, I mean, it's obviously all printed out on one line, but we're about to fix that because when we do scanf, we automatically get a new line. So we need to actually get the inputs after the questions, don't we? So we're taking in floats, or at least that's what we did before anyway. And we're taking in, we need an address for the scanf, so we're taking in the address of the input at position I. So now we can do 1, 0, 0, 1, 1. And the program works, and it's a lot more compact than what we had before because all that's happening now in just 2 statements that are just being looped through. So next we've got to figure out what we're going to do with our weights. So we've got weight 0 equals 0.8. How do we vary this with the value of I? We could obviously sort of set the weights before the for loop, couldn't we? And we could do weight 1 and so on, and weight 2, but really these weights relate directly to the question, so ideally we want this get question function to set the weights, don't we? So let's do that. Let's take another parameter. We're going to take the address of the weight at position I, so we can modify the value of the weight in this weights array, and that means we need to receive an address of a floating point value, and we can just call it weight. So this star operator is what gets most people messed up with C programming. As soon as they start trying to do things like this, then they just get loads of compiler errors and don't know how to fix them. It's quite simple really. So we're sending an address over here, an address of a floating point value, and we need to receive not a floating point value but an address of a floating point value. So this is a pointer to used in this context. So it's a pointer to a floating point value is what the star operator means in this context. And we're just calling it weight. We can call it whatever we want. We could call it memory address of a float, for example. That would be a lot to type in. So we'll just call it weight. And then when we're going to set the value, so we want to do weight equals 0.8, for example. But this weight is a memory address. It's not a floating point value, so we can't assign a floating point value to a memory address. We need to dereference that memory address and assign the value. Now I'm going to do a good part on pointers. In fact, I might do several parts on pointers and just re-explain it in a few different ways, because it is the trickiest part of C programming, but it's also easier than it's usually described as. It's once you get the concept of there's a difference between a memory address and a value, then you're halfway there. Then you've just got to learn when to put these stars in, basically, and then and what they mean in the two different contexts that they can mean. So for now, we'll just do this today. It's more just an example of refactoring this program into a proper C program. So we'll do a dedicated part to pointers and memory addresses and that kind of thing. But at least here we get to see them in action. So let's vary these inputs. So 0.8, that's probably about right for do you like computers. 0.7 if you like programming. Are you dedicated? We'll make that 0.5. It's important, but you could just take your time with it and go slow and learn it slowly, couldn't you? Are you willing to give up your social life? Make that a 4. It's not that important. You can obviously have a social life and be a programmer, but the less social life and the more programming, the better you're going to get. And then can you copy and paste? We'll make that a 0.7. That's quite important. You've got to be able to copy and paste to get anywhere in programming, haven't you? Right, so now by the time we've got here, after that printf and scanf, we've set the weight and we've got the input. So all we need to do is calculate the value of the perceptron. We're going to do this as we go around the loop. So we're going to have to do a plus equals. So that means that this is going to need an initial value, because we've got plus equals to a value where we haven't set it to at least something, and in this case it's going to start off at 0. And we're going to do x at I multiplied by weight at I. And then we can confirm all this is working by just printing out the value of the perceptron. And we can do p equals %f p. Let's see if this works. Oh, I've spelt weight wrong somewhere. W-E-I-G-H-T, W-E-I-G-H-T. That doesn't look right up there, does it? W-E-I-G-H-T. Do you like computers? 1. Do you like programming? 1. Are you dedicated? No. Are you willing to give up your social life? No. Can you copy and paste? No. The perceptron value is 1.5. What if we do all 1s? Perceptron value is 3.1. So it's working. The program is working. So this is pretty much what we had before. We're going to make this program better. So first of all, let's print out a title. Perceptron. At the moment we do answer 1 or 0. Oh, no, we're going to have to do some new lines there, aren't we? /n/n /n, just one /n to begin with. We don't really want to answer it in 1s and 0s. It might make sense to what the program's doing, but it's not a very user-friendly kind of way of doing inputs. What we want to do is yeses and nos. When we do that, the program all goes wrong. So we need another function, don't we? So, and we need another variable too. So what we really want is a car input buff, an input buffer, because yeses and nos are characters. They're not numbers, are they? So we're going to change this scanf function to take in the address of our input buff. Now with scanf and characters, do that. Put a space there. We'll cover Y another time. It just skips all the white spaces. There's other functions we can do to get user input, and maybe another function would be better here. But so we don't have to introduce too many new concepts. We'll just put a space in before our %c, and we're going to need a set input function, aren't we? Where we pass the input buff and the address of the input at position I, because we're going to this set input is going to actually set the value of I rather than scanf setting the value of I. So let's make that function. So we could probably make it as a void function, set input. and we're taking a car input buff, and we're taking a pointer to a float, and we're going to call that input. So once again, we're passing the memory address, the address of the input at position I, which exists in an array. So we're just passing a single floating point, the address of a single floating point value, and we're capturing that there with this float start input. And what we're going to do, we're going to need a couple of ifs. Let's scroll that up a little bit. We're going to need an if input buff equals the letter Y. I suppose we could do or input buff equals a capital Y, just in case someone's got caps lock switched on. And we're going to set, if it's a Y, we're going to we're going to have to dereference our input and set it to 1. And then we need to do the same thing for input buff equals no, or input buff equals capital no. And then in this case, we're going to dereference our input address, and we're going to set it to 0. So let's see if that works. We're going to have to change the title though, aren't we? Enter Y or no. Yes, yes, no, no, no. Perceptron 1.5, yes, 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 yes. 3.1, so that works. But we do have a bit of a problem. Let's find out what that problem is. What if I put L or A or Q or W or B? It doesn't work. We're not validating that user input, aren't we? So we need to have another case here. So instead of having this if, we're going to do an else if, and then we're going to do an else. So we want this else to sort of represent error invalid input, don't we? How are we going to do that? We need to make this an int type. And if everything's okay, we're going to return a 0. If everything's not okay, we're going to return a -1. So we can capture that in our loop. We can wrap this in an if. We can say if set input, let's put some spaces in to see this a bit better, is not equal to 0. So usually the function returns 0, but if the input isn't Y or capital Y or N or capital N, we're going to return a -1. And we can print out some kind of error message. Error invalid input. And that's going to go to the standard error. And we can return 1. We're in the main function, so if we return 1 at that point, the program's going to quit, and it's going to requit with a return 1 value, which is going to represent an error. So let's try that out. So we can do yes, no, but if we answer P, it says error invalid input and the program exits. So we've got a bit of validation in there now and a bit of error handling. Probably do that as well. So what about our output? We don't just print out the value of P, do we? We want a out. Yeah, we'll just call it output. We're going to make an output function. We could definitely make this as a void output. And we're going to have to take the value of P, so we need to pass that, don't we? Output P. So we've calculated our perceptron value, we're now going to pass it to the output function. And here we just do our normal if, don't we? So if else, if P is, we said 1.5 before, didn't we? We're going to print out yes. If not, we're going to print out no. See if that works. Yes, 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 yes. Should be a yes. No, 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 no. It's a no. Excellent. We don't really want this magic number to be here as well. We're going to define that too. So we're going to call that threshold, and we're going to define that up here. We're going to do define threshold 1.5. And we've got a working program. Is there anything else we can improve? I know one thing we can improve, so actually let's just change this. So what if we mismatch our input count to the number of questions we've got defined? What's going to happen then? If I set that to 6 and we've only got 5 questions defined. Yes, 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 no, no. Segmentation fault core dumped. We've caused a critical error in our program by making quite a simple mistake there, haven't we? So how are we going to handle that? Well, the problem is where it's occurring is down here in our get question is not returning anything. So we need to set a default case. We'll just put default break, and we can put return error. Let's see if that works. Yes, 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 yes. And we get an error, but then the program sort of hangs there waiting for an input and then carries on as normal. We don't want that to happen, do we? So we're going to have to catch that error somehow, which means we're going to have to include the string library. I try and avoid bringing in libraries just for a single use, but here we are. So what we want is this get question to be a car star get question, and we're going to call that str, and then we're going to print out str. Just check that works. Equals. So we're going to create a string every time we go around this loop and set it to get question, and then just print out the value of that string. Makes things a little bit more manageable. Right, so that works. So what we're going to do is we're going to run a string compare function on that string and make sure it doesn't say error. So we're going to need an if, and we want strcmp, which is a function. We can look at it. String compare two strings, C standard library, string 1, string 2, and what does it return? Returns an integer indicating the result of the comparison as follows. It returns a 0 if string 1 and 2 are equal. So we're going to have error compared with str, but if they're equal it's going to return 0, which means this isn't going to run. So we want that to invert that sort of functionality, so we put a not logic in front of that. So we say not string compare error string. So in the case that this matches this, then the if statement is going to run, and we're going to do fprintf error no question defined, check inputs, and once again we're going to return a 1. Let's see if this works. Yes, 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 yes. Error no question defined, and the program terminates. Now we've just done that because we've caused a seg fault by making quite a simple programming error, and rather than having to debug the entire program, we can just sort of handle that case, can't we? So we've got a pretty good working program. We can make it look a bit better, can't we? Shall we do a bit of regex? Well, first of all, I would like the questions to be indented. So /t, 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 and we'll do that as /t as well. No, we won't. We won't do that as /t, otherwise the string compare won't work, will it? We'll just leave that as error. And we're going to /t these as well. Let's just see how that looks. The questions are indented now, and the output is indented. We probably want the output to be on a new line as well, don't we? So let's just stick a new line above all that. Right, so we've got the answer is yes, learn C. No, learn JavaScript. We want these to be colorized, really, don't we? We want yes to be green. How do you do that? You do 0, 3, 3, open square bracket, 1, colon, what's green? I think it's 32, M. Then we do /033 0M. And then for red, we do /033 open square bracket, I think it's 31. And then we do /033 open square bracket 0M. I don't really commit regex to memory, but I do like altering colours, so I've pretty much got colours down. Yes, learn C, and then we run it again. No, learn JavaScript. Perfect. So it would be nice if we could see the output of the perceptron as well. So let's do another new line, and then we're going to do a printf %f p and print out the value of p and go back to having p equals. Yes, 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 yes. P equals 3.1. 3.1 isn't really a very useful output. It's kind of arbitrary. It's dependent on the number of inputs and the nature of the weights and the size of the weights. It would be good to represent the P as a percentage, wouldn't it? That would be more helpful. That would give us a better idea of what that value means. So if we want a percentage, we're going to have to figure that out as we go along. Obviously, it's 1 times all of the weights is the maximum value, and we want to divide our value by the maximum value. So we need a P max. P max, and we can work this out as we go along, can't we? So we can do P max plus equals 1 times the weight at I. That'll give us our P max value. We're going to pass that to our output. Float P max. And we're going to, let's get rid of that and put all these on new lines. We'll call this %P equals %F %%, and we do P divide P max times 100, and we should probably put them in brackets. See if that works. Yes, 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 yes. 100%. No, 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 no. 0%. And somewhere in between. Yes, yes, no, no, no. P equals 1.5, 48%. There we go. So we've refactored the program. So let's look at what we've ended up with. Let's zoom right out. First of all, our main function looks like a C program now, doesn't it? And secondly, we handle all the errors that we can occur from user input, and even programming errors like mismatching the number of inputs with the number of questions we've got. And if we want to add more questions, we can just add a question in here with a weight and increase the input count by 1. So this is not a bad Perceptron program now. Got a bit of white space there we can get rid of. And we've even added a bit of colorized input. I think there's much more we can do to make this a better program, isn't there? I know what an error is going to happen. Something that we can do. What happens if I do y? The program, it fills out all the values, 3.1 100%, but we don't want the program to work like that, do we? So we've got another error that we need to catch here. It's quite an easy one to do. After we've scanned F, we can do a while getChar is not equal to new line. I reckon that'll solve it. Yes, let's see. What about if we put no input? I suppose, yeah, it'll just wait for an input. Right, we've got a working program, so let's actually run it properly. Do you like computers? Yeah, I like computers. Yeah, I like programming. Well, I'm going to answer yes to everything, aren't I? Let's pretend it's not me. Are you dedicated? No. Are you willing to give up your social life? Absolutely not. Can you copy and paste? Can't copy and paste. No. Learn JavaScript. So if you like computers and you like programming, but you're not dedicated, you're not willing to give up your social life, and you can't copy and paste, you should learn JavaScript. According to this Perceptron program. What if you don't like computers and you don't like programming, but you are dedicated, you are willing to give up your social life, and you can copy and paste? You should still learn C, even if you don't like computers and don't like programming, just on the basis of being dedicated and willing to give up your social life. Well, I'm not sure it was an accurate model of a question, this, but it does work. The program works, and that's the important thing. So what were we going to discuss? We're going to discuss this, the nature of the output. So shall we? I haven't got this drawing thing plugged in, have I? Let's plug that in. So the output, we've represented it here as a percentage, but really it's just a value, isn't it? And down here we have mathematical notation. So let's write that out. So we have in maths the sum of operator, which so say we've got the sum of, like we've got here, xi times wi. So if we've got lots of them, we do x equals 1 up until n. So how you read this is just like a for loop. So x starts at 1 all the way to the number, the n, the number of these that you've got, and you do x at position I times w at position I, and then you go to the next one, x at position I, and then this sum of means add them all together. So that is how we write our perceptron algorithm as a mathematical formula. So what does, let's get rid of all that. And our perceptron, P, equals some kind of value between, by the looks of it, 0 to 3.3 in our example. You know, it could be anything. And we set a threshold of 1.5. And then we do a compare, don't we? So the ultimate output of the perceptron, if it's less than 1.5, the output equals 0. If we're above the threshold, the output equals 1. So we can graph that, can't we? Let's get rid of all that actually. So we did a graph of that, and we got some. We do a graph coordinate system. We'll use a different colour. So we've got the output of the perceptron, which is y, and then we have our sum of our weights and inputs, which are times together. And we've got 0 there, and we've got 3.3, which is the maximum value. We've got 1.5 here, which is our threshold. So the output of y is, if we go for another colour, let's go for blue. The output of y is 0 if the result of our perceptron is less than 1.5. In all the different cases, if it's 1.5, then it's 0. So we'll make that a 1 and that's 0. If the output is more than 1.5, that jumps up instantly and then graphs like that. And everything above 1.5 is considered an output of 1. We call this a binary step function, which is self-explanatory because it's one great big binary step, isn't it? It's a binary output. We can either have a 0 output or a 1 output, and it changes in a single step. And this falls under the umbrella, no, not a very good circle, of an activation function. And there's lots of different activation functions. So we've just made another activation function. We've made a percentage activation function in this example, haven't we? We've made %p 51%, which is a different kind of activation function, a different kind of way of representing the output of the perceptron. And if we built a multi-layer perceptron, so let's get rid of all that. We won't draw the weights and biases. We'll just have P1. P2, which can have a series of inputs and weights. So we could have one set of questions here and another set of questions here. So this could be lifestyle questions, like in a survey. Lifestyle questions, and here we could have technical questions. and we could feed the output of that perceptron and the output of that perceptron into another perceptron, and consider this to be the input of the output of that perceptron to be one input and the output of this perceptron to be another input, and this arrive at an ultimate output where we apply the threshold to it. And we could send these across as percentages, and then if our threshold is above a certain percentage, we can arrive at the same thing. We'll have a yes, learn C, or no, learn JavaScript. You can really read my writing there, can't you? Well, it's more of a just getting the basic idea of what an activation function is. So we output our perceptron, outputs a 0 or a 1, but we could output a percentage. We could output lots of other things. Depends on the activation function we apply to the perceptron, and we could feed that output into another perceptron, or we could feed it into something else. And again, this is the beginning of AI. This is where it all starts. The purpose of this part was just to go through refactoring this program and just do a bit more C programming and pass around a few weights. But the basic idea of connecting up perceptrons is very similar to connecting up a neural network. And that about does it for this part. So we've ended up with this program, which it was just a run through really. So make of it what you will. See you next time.